Good afternoon, dear students. So, in the last class, we have started with chemical kinetics. Okay, so same today also we are going to continue with the same, that is chemical kinetics topic. Okay, so we have seen yesterday's few nearly some 25 questions. So we are going to continue with the same today. So we'll see some more questions. Okay, so as as it is very important chapter, so I've taken it for 2 days. Okay, fine. Okay, so let us continue. So this is a question. This we have done. So next question we'll see. So 51 question. Okay, 51st question. If 60% of a first order reaction was completed in 60 minutes, 50% of the same reaction would be completed in approximately A, 45 minutes, B, 60 minutes, C, 40 minutes, and D, 50 minutes. So here the values of log 4 and log 6 are given. Okay. So you can utilize this while using this while solving the problem. So how will you calculate this? Try to answer. So see what all things are given. So concentration is given. So first order reaction. So for first order reaction, we know that, right? Here, we know that. So for first order reaction, okay, how is the rate equation given as K is equals to 2.303 by T okay, log of A by A minus X. Right. Now here, what is T given? So if 60% of the first order reaction was completed in 60 minutes, so the time, so at T is equals to 60 and this is what X will be 60%. Okay, 60 X is 60%. So how much work is completed? Okay, 60%. So substitute in that equation. So K is equals to 2.303, T is 60, log of 60% means what? 100 minus this, right? 60. So A is what? A is 100 and A is 100 minus 60. Okay, so this will be how much? It will be, so we'll go stepwise. Okay, so this will be 60. So it will be 2.303 by 60 log of 100 to 40. So now you solve this. So this is for at work. Okay, that is 60% of first order reaction was completed in 60 minutes. Now we have to calculate for 50%. Okay, 50%. 50% means at T half. At T half. So at T half, we know that 2.303 upon 2.303 upon that is 50% of the work. Okay, so K. So just see how much K value you will get from this. So log of 2 point this. So take K value from this, how much you are going to get? So 2.303 divided by 60. So this comes to 0.0383. Then log of 100 divided by 40 is 2.5. Okay, so log of 100 by 100 divided by 40 is 2.5.
40 ಬರುತ್ತೆ ಅನ್ಸುತ್ತೆ ಸಿ ಆನ್ಸರ್ ಅನ್ಸುತ್ತೆ.
So here How much you're getting? 40. Okay, we'll see. So here 0.0383, okay, into log. So just see how much you're going to get. Log of 25. Log of 2.5 will be 0.3979. So multiply this by, so 0.3979 into
That was
0.0383. Okay, so you have to get to this k value. Okay, you have to get to this k value. So after solving, how much you are going to get? You have to get this as 0.0153. Okay, so we know that TF is equals to 2.303. Okay, then 0.0153 into K log of, so 50% means 100 upon 100 minus 50. So this is what? So this is T of half will be T of half will be what? So T of half will be, so this will be 2.303 divided by 0.0153 into, so this will be log of 100 by 50. Okay, so that is log of 2. So here it will be log of 2. Log of 2 value is given. No, log of 2, it is 0.3010. So answer, okay, after solving this, you have to get it as 45.3 minutes. Okay, who all have got it as 45? Yes, Tasmia, Pavitra, and Aishu. Yes, very good. So you'll get it as 45 minutes. Okay, so 45 is option number A. 45 is option number A. Okay, fine. So we'll go for the next question. Half-life period of a first order reaction is given. So half-life period of first order reaction is T half is given as 1386 seconds. Okay. Now specific rate constant of the reaction is. So we have to calculate the specific rate constant of this reaction. Okay. How will you calculate this now? So for first order reaction, we know that T of half will be equal to 0.693 by K. So now K, what we have to calculate the K. So K is equal to 0.693 by T of half. Okay. So it is how much? So it is 0.693 and your T half is 1386. See, calculate how much. So it will be 0.693 divided by 1386. So it is 0.0005. Means if you transfer this decimal to right hand side by 3, okay, so it will be 0.5 into 10 raised to minus 3. So 1 to third position. So 0.5 into 10 raised to minus 3 per second. Okay, so it is option number, yes, B. Option number B, yes. Tasmia, Sumana, Aishu and Swati. Yes, very good. Your answers are right. Okay. So like this. So everything is given. Very simple question. Okay, for half-life period of first order reaction. Next question. 3A giving you B plus C, it would be a zero order reaction when? So when it will be a zero order reaction, A, the rate of reaction is proportional to square of concentration of A. B, the rate of reaction remains same at any concentration of A. C, the rate remains unchanged at any concentration of B and C. D, the rate of reaction doubles if concentration of B is increased to double. Yes, how will you answer this? So the reaction is 3A giving you B plus C. Okay. So what is rate given as? Rate of zero order reaction is concentration raised to 0. That is what will happen. The rate will remain same at any concentration of the A. Okay. So it is independent of what? It is independent of concentration. So it is option number B. So the rate of reaction, it will remain the same. Okay, it will remain the same at any concentration of A. So option number B is the correct answer. Yes. Swati, Sumana, and Vedvati have answered it right. Okay, so the answer is B. So remember that for zero order reaction, when we write the rate, okay, the rate will remain the same because we know that for any concentration, okay, so the concentration at any concentration, it is independent upon the concentration of A. Okay. So let us go for the next one. So for the reaction 2A plus B giving you 3C plus D, which of the following does not express the reaction rate? Yes, which one? So this is a reaction 3A, 2A plus B giving you 3C plus D. So which of the following does not express the reaction rate? So these are the four options, right? So minus, yes, so minus B by dt. So when you write the reaction rate for this, so minus d by dt, so this will be minus half of d by dt of concentration of A minus d of B of dt, okay, giving you minus 1 by 3 d of C by dt plus 3 d by dt. So this is correct about correct. This is correct. No, sorry, this is plus, no. So here, just a second. Okay, so when we write the rate equation, okay, so here it is d by dt, correct? Then this is correct, and this is correct. Minus 1 d by dt. So this will be plus d by dt when it goes there. So this is minus. So when we write the equation, rate equation, okay, so what will be? So we have seen, okay, so it will be, so here it would have a negative sign as a product, okay. So here in the product, there should not be a negative sign, okay, it should be a positive sign. So when we are writing the reaction rate here, so here, so this will be, if you are taking minus common here, so this will be plus, yes. Okay, so option number D, I say it as option number D. So option number D. Okay, so in this given option, you can see that minus dc by dt. Okay, it will not represent a reaction rate because it should not have a negative sign. Okay. So this will be it is formation of product. So formation of product means it should have a negative sign. Okay, it should have a negative, it should not have a negative sign, it should have a positive sign. Okay, so it is option number D. Option number D. So it should have a positive sign in the formation of products. So option number D is the correct answer. So Aishu, Adhika, then Vedvati have answered it right. Okay. Let us go for the next question. So 36th question. The reaction A giving you B. It follows first order kinetics. The time taken for 0.8 mole of A to produce 0.6 mole of B is 1 hour. Okay. What is the time taken for conversion of 0.9 mole of A to produce 0.675 mole of B? So these are the options. So D option is 0.25 hour. Okay. So C, solve it. So for the reaction A plus B, it is a first order reaction. Okay, it is a first order reaction. It is what? It is a first order reaction. Now what all are given? Given is 0.8 mole. Okay, A is equals to 0.8 mole. Then concentration 0.8 mole. Then it will produce 0.6. So A minus X is what? 0.8 minus 0.6. So it is 0.2. So what is the time taken for conversion of A to produce B? Now first we'll find for this equation. So for the second is A is equals to 0.9 and A minus X is what? 0.9 minus 0.675. So this is how much? This is 0.225. Now put the equation. So K is equals to 2.303 by T log of 0.9 by 0.225. Just see how much it is. So 2.303. Okay, 2.303 time is so so we have to find the time. So log of 0.9 to the this will be log of 4. So do this and see how much you're getting. Let me write it again. See here. Let me write it here. So what is given? A to B. Okay, for first order reaction. What all are given? A is given. A is 0.8. Then A minus X is what? 0.8 minus 0.6. That will be equal to how much? 0.2. Now K for this. So the rate constant is equals to 2.303. Okay. What is time? Time taken is 1 hour. It is taken as 1 hour. Then log of 0.8 divided by 0.2. So how much it will come? So 2.303 log of 0.8 divided by 0.2. How much it will come? 0.8 divided by 0.2. It is 4. So log of 4. Now for second, again A is given as 0.9 and A minus X is how much? 0.9 minus 0.675. How much it will come? 0.9 minus 0.675. So this comes to 0.225. It comes to 0.225. Okay. Now K is equals to 2.303 by T log of A by A minus X. So 2.303, we have to find the time. Okay. Now K, here, what is K? Here, from this we got the K. K value is 2.303 log of 4 of T. Then log of, this is how much? Log of A is 0.9 divided by 0.225. So 0.9 divided by 0.225. So this comes to be again log of 4. So 2.303 log of 4 is equals to 2.303 by T log of 4. Okay. So how much it is? So T is equals to, so if this will get cancelled, so T is equals to 1. Okay. So after just substitute, so it will be T is equals to 1. Are you getting the same? So it should come answer as 1. Answer should be 1. So here 2.303 log of 4. So this is multiplying. Okay. Now this is what? Here what is happening? Here we are multiplying, right? So here it is a division. So this will go and multiply here. Okay, so this is divide. So this will multiply. So 2.301 into this will be 1. So T is equals to 1. Okay, so it is 1 hour. Understood? So it is option number B. Option number B. Is it clear? Simple calculation. Okay, so simple calculation. So it will come. So here we have substituted K from here. Okay. From the rate constant from the first reaction. And then we have substituted and then got the answer. Okay. Next question. The rate of reaction between two reactants A and B decreases by a factor of 4. If the concentration of reactant B is double, the order of this reaction with respect to reactant B is. Now this question, 37th question. So rate is given. Okay, so rate of one reaction. Okay, it is given as rate of concentration of A raised to X and B raised to Y. So we know this. Okay. Now, if the rate of one reaction, if it is the two reactant between A and B decreases by a factor of 4. So if it is decreased by 4, then the concentration of A is same, but that of B will be doubled. Okay. So B will be doubled. Now, how we can write this? We can write it as 4. We can write this as rate of first reaction into this will go and multiply. So 4, 1. Okay. Then AX to B into Y. Now from 1 and 2. From 1 and 2, what we get from 1 and 2? So write 1 and 2. So this will be, so this is first equation. So we'll write first equation first. That is K A raised to X B raised to Y divided by, okay, divided by 4. 4 is equals to K A raised to X and 2B Y. Okay. So what is happening here? The order of this reaction with respect to the reactant B is, okay. Now here, this and this get cancelled. Okay. A and this will get cancelled. So only with respect to B. So how much it will be? So this and this will get cancelled. So it is B raised to X by 4 is equals to 2B by 4. So your 1 by 4 is equals to 2B by, okay, I'm just transferring here. So 2B by B raised to X. So that will be equal to 1 by 4 is equals to 2 raised to Y, because B and K will cancel. So 2 raised to Y, or, okay, so this will go there. So 2 raised to minus 2. So that is 2 raised to Y. What is Y? Y is nothing but minus 2. So it is B. Are you getting the same? Yes, Sumana has answered it as B. Good. Okay, so it is like this. So these are equations. Okay, equations given. We have to just substitute and get the answer. Okay, so from rate equation 1 and equation 2, we get the equation. Then we just go on cancelling it. Okay, so here you can see, so the similar terms we have cancelled. Okay, then we have got this. Then here 1 by 4 is equals to, so here BB bit cancel. So 1 by 4 is equals to 2 raised to Y, or 2 raised to minus 2. So because 4, if you transfer there, it becomes square of that, right? So it will get multiplied. So it will become square. So 2 square is 4. So it will be, what is 2 raised to Y? Y is nothing but your minus 2. So option number B is the correct answer. Okay. Let us go for the next question. So 39th question. The rate of reaction between A and B increases by a factor of 100. Okay. When the concentration of A is increased by 10 folds, the order of the reaction with respect to A is A 10, B1, C4 and D2. 39th. Again same as first one. So rate of first equation, it is what? How we write the rate? So E raised to L and B raised to M. Okay, we'll take like this. Then rate of second equation, how much it is? So what is happening here? A rate is increased by 10 folds. So X raised to, okay, concentration of 10. So it is K into 10 A raised to L. Okay, and B raised to M. So we have what happens? The concentration of A is increased by 10 folds. Now, hence rate. So we'll just divide 2 by 1. So rate of 2 and rate of first equation is equals to how much it is? The order of the reaction. So the rate of reaction between A and B, it increases by a factor of 1. So it is increased by 100. So that is 10 raised to L. Okay, so what is 10 raised to L? So 100 is nothing but 10 raised to 2. So that is 10 raised to L, and L is nothing but your 2. Because what is 100? 100 is 110 square is 100. Okay, so L is your 2. So it is option number D. Option number D. Okay. So similar question it was. Let's go for the next question. Then 40th question. Okay, 40. For the reaction H2 gaseous plus Br2 gaseous giving you 2HBr, the rate law is rate is equals to, okay, which of the following statement is true about this reaction? The reaction is second order, molecularity of the reaction is 3 by 2, the unit of rate constant is per second, and the molecularity of the reaction is 2. So this is the reaction. I'll write the reaction. So H2 gaseous plus Br2 gaseous giving you 2HBr. Okay. So here, what is the rate law? Rate law is given as R is equals to K H2 Br2. Okay. Raised to half. Order of reaction. How do you calculate order of reaction? Calculate all now. Order of reaction is, so here it is 1. So 1 plus half is 3 by 2. Then how do you calculate molecularity? Molecularity of reaction. Molecularity of reaction is what? It is 1 plus 1. Okay, it is 2. Molecularity is 2. Okay, so molecularity is 2. Then what is the unit of rate constant? So rate constant is R by H2 Br2 by half. So this is mole per liter and per second. H2 is mole per liter, and for Br2 it is mole per liter 1 by half. Okay, so cancel. So mole get cancels. Okay, liter get cancels. What is remaining is mole minus half, liter minus half. Okay, because you are multiplying this here, and per second. So this is the unit of your this. So what is the correct answer? So which of the following statement is true? So the reaction is second order reaction. The reaction is 3 by 2. Okay, so this is wrong. The molecularity of reaction is 3 by 2. No, molecularity of reaction is 2. So this is also wrong. The unit of this is per second. No, this is also wrong. Then the molecularity of the reaction is 2. Yes, so option number D. Okay, option number D. Are you getting the same? Option number D. Okay, Adhika, Sumana, Aishu, Vedvati, Swati have answered it as D. Okay, so you get like this. So, or if order of the reaction is given, if the reaction is given, so you have to calculate the order of reaction, molecularity, and just see what is asked. Okay, next question. Consider a reaction A, G plus BH giving you products. When concentration of both the reactant G and H is doubled, the rate increases by 8 times. However, when concentration of G is doubled, keeping the concentration of H fixed, the rate is doubled. What will be the overall order of the reaction? Yes, what is overall order of the reaction? So overall order, okay, overall order is calculated as sum of orders, okay, with respect to reactants. So with respect to each reactants, we have to calculate the sum of the order. So if we consider, so let the order Okay, if you consider, let the order be X and Y. Okay, for G and H. So for G and H, so G and H are the this. Okay, for that, let the orders be X and Y. Now, exponential number. Okay, so if you have 1, 2, and 3. Now here, so here, okay. So for G and for H, and what is the rate? So if G is equals to A, what is B is your B. Rate is R. If the order is increased by how much? 8 times. Okay. So if it is increased by, if the rate increases by 8 times, however, when concentration of G is doubled. So if we concentrate, if we increase the concentration of G, okay, keeping the concentration of H fixed. So here in the first, okay, what we are doing, we are going to double both. See here, when concentration of both the reactant G and H is doubled, the rate increases by 8 times. So let us double both. What will happen to the rate? Will increase. Now, when the concentration of G is doubled, so let us double the concentration of G and we'll keep the concentration of H fixed. What will happen to the rate of the rate is also doubled. Okay, the rate is also doubled. Now, overall order of the reaction, how do we calculate the overall order? You have to calculate the sum of the orders with respect to reactants. Okay. Now, we know that rate is equals to K into G by X and H by Y. Okay. Now, what is X? X is equals to 1 and Y is equals to 2. Okay. So, Y is equals to X is equals to 1 and Y is equals to 2. So, apply that. So, applying this from 1 and 3. Okay. From 1 and 3, what we get? We get that rate is doubled. Okay, when concentration of G is doubled, keeping your concentration of H constant. So from 1 and 3, what you can observe that when concentration of G is doubled, keeping the H and this constant, okay, so rate is directly proportional to concentration of G. So therefore, X is equal to 1. And from this, from 2 and 3, okay, now compare 2 and 3. So from 2 and 3, what is y? Y is equal to 2. Okay, you can see what is the coefficient? It is 2. So y is equals to 2. Now what is the overall order? So overall order is 1 plus 2 is equals to 3. So option number D. What is the overall order? Overall order is D. Okay, option number option number is D, that is 3. So like this. So if you see the first and third, when concentration of A is kept, okay, if the rate is doubled, okay, when concentration of the rate is doubled, when the concentration of G is doubled, okay, keeping that H constant. So rate is directly proportional to G. So you can see that X is equals to 1. And if, okay, and if this what, if if you see first and third, second and third now, okay, what is happening here? You can see that this is double. Okay, if G and H, both the rates are double, what is happening to the rate? Rate is also getting double. So Y is equals to 2. So overall order can be calculated by sum of orders with respect to the reactants. So it is 1 plus 2, it will be 3. So answer is 3. Okay. So let us go for the next question. 42 question. For the reaction A giving you B, the rate law expression is rate is equals to K, okay, concentration of A. Which of the following statement is incorrect? A, the reaction follows first order kinetics. B, the T half of the reaction depends on initial concentration of reactants. C, rate is constant for the reaction at a constant temperature. And D, the rate law provides a simple way of predicting the concentration of reactants and products at any time after the start of the reaction. Okay, so for the reaction, so the rate law expression is given as rate is equals to concentration of, this is rate into concentration of A. So for this, we know that which is the correct statement. Yes, which is the incorrect statement they have asked. So whenever we are talking the reaction for first order reaction, it will follow the first order kinetics. Okay, for this expression. Then K is constant for reaction at constant temperature. So this is also correct. The rate law will provide a predicting the concentration of law at any time. So this is also correct. So T half. So T half of the reaction, it depends on initial concentration of the reactant. Okay, it is independent. So it does not depends. The T half of the reaction, does not depends. It is independent. Okay, remember that it is independent of initial concentration. Okay, it is independent of initial concentration. So option number B. Okay. So next question, 43rd question here. The chemical reaction 2O3 giving you 3O2 proceeds as follows. So this is a reaction. So the rate law expression should be, so what is the rate law expression? So O3 giving you O2 plus O. Okay, this is a fast step. Then O plus O3. Okay, slow step giving you 2O2. Now if you take the rate of this, so it is O2 into concentration of O divided by O3. Okay, and the rate is given as K dash is equals to O3 into O. Okay, so O3 into O, K dash of O3 into O. So if you take this as first one, okay, so if you take rate is equals to K into O3 into K of O3 by O2. So this will be K of O3 square divided by, so this will be O2, right? So O2 will go up. So it will become O2 raised to 1. So option number, which one is the correct answer? Option number B. Option number B. Okay, so this is from the equation 1. So put rate. So you have to put this as in equation 1. So from 1 you will get this. Okay, if you substitute this in 1, you will get the rate for this expression like this. Okay, so a bit tricky one. Fine. Next question, 44th question. A substance A decomposes by a first order reaction starting initially with concentration of A is 2.00 m, and after 200 meters concentration of A becomes 0.15 m. For this reaction T half is. So we know that initial concentrations are given here. So what are the given things? Shall tell you the given things, substitute and get the answer. So what all are the given things? So 44. So initial concentration of A is given as 2.00 m. The time taken is how much? 200 minutes, sorry. And the final concentration is how much? That is A minus X is equals to 0.15 m. Okay, so first order reaction K is equals to 2.303 by T. Okay, log of A by A minus X. Now put the values. T is 200, then log of A is 2.00 and log of A minus X is 0.15. Now put the values. 2.303 200 into log of this how much? How much you're getting? Just the log of 2.00 divided by 0.15. So this 13. So log of 13. Yes. How much answer you're getting? So log of 2 is how much? Log of 2 is 0.301 and log of 0.15 is minus 0.823. So if you multiply this here, it will be 2.303 by 200 into log of, sorry, not log. We are removing the log, no? Log is over. Now into what you are going to do? 0.301 plus 0.823. Just see how much you are getting now. So multiply 2.303 divided by 200. How much it will be? It will be 0.0115, okay, into 2.301 plus 0.823. So it is to 1.124. So do this. So it will be 0.0115 into 1.124. The answer you are going to get is 1.29 into 10 raised to minus 2 per meter. So this is time with the T half. Now T half is what? T half is 0.693 by K. So what is K? K value we got. K value is 1.29 into 10 raised to minus 2 and 0.693. Do it this. Yes, now you see. So 0.693 divided by 1.29. How much you are getting? The answer I am getting is 0.537. So it is 53. Yes, A. Yes, Aishu has also got A. What about others? Are you getting the same? A option. So 53.7 minutes. Okay. So T half. So like this, you have to calculate the T half. Is it clear? Is this question? So T half, half-life period. Okay. On basis of first order reaction. So it is very important. So questions are mostly asked from that part. Okay. So next question, 45th question. Half-life of a first order reaction is 4 seconds and the initial concentration of the reactant is 0.12 m. Okay, molar. The concentration of the reactant left after 16 second is. Yes. How will you solve this? So T half is given. T half of the first order reaction is 4 seconds. The initial concentration is given. Initial concentration is 0.12 molar. Okay, so that is A naught. And the concentration of the reactant left after 16 second is. So T half is this and time is 16 seconds. So N is equals to T by T of half. What is T is 16 and this is 4. So therefore T is equals to N into T of half. So now here A is equals to A naught of 1 by 2 into N. What is initial concentration is 0.12 into 1 by 2 by 4. How much it is? 0.12. 2 into 4 is 16. So this will be 0.0075 molar. Okay, option number A. Option number A. So A naught here we have taken as initial concentration and A is what? We are finding the concentration of reactant which is left. Okay, after the time T. So it is what? It is 0.0075. So like this. So by this we can calculate the N. Okay, how much this is. Okay. So then that we can substitute here. So A is equals to the concentration of the reactant which is left is equals to initial concentration 1 by that is half raised to N. So by substituting the values we will get it. Okay. Then 67th question. For the reaction 2H2O2 giving you 2H2O plus O2. K that is rate is given it is which order reaction? Can you tell me which order reaction? Zero order, first order, second order, or third order? Yes. So the rate equation is given. So you have to tell which order reaction it is. Yes. So your H2O2, you can see at H2O2, the rate is equal to 1. This order of the reaction is equal to here how much it is? H2O2. Rate is given here. So it is raised to 1. So it is first order reaction. Yes, first order reaction. 68th question, order of reaction is decided by. So how the order of reaction is decided? A, temperature, B, mechanism of reaction as well as relative concentration of reactant, C, molarity, or D, pressure. Yes, how the order of reaction is decided? It is decided, okay, it is decided by concentration of the reactants, okay, which is appearing in the lowest step. So it is B option. Next question, 69. So the hypothetical reaction A2 plus B2 giving you 2AB follows the following mechanism. Okay, this is a mechanism which is followed. What is the order of the overall reaction is? So the reactions are given as A2 plus B2 giving you 2AB. Then what are the steps? So A2, it will give you fast step. It dissociates into A plus A. Then A plus B2. Okay. In the slow step, giving you AB plus B. Then A plus B fast, giving you AB. Okay. Now here, so the rate law. So the rate law is what? Rate law is rate of A into B2. Okay. Rate of A into B2 for this rate law. Okay. Rate of A into B2. So put this value of A from first reactions. Okay. And we can obtain that. So this is 1. So A is the intermediate step. So we'll follow the first and third one. So the rate according to that, okay. So order of reaction. So this is 1 by half. Okay, this is 1 by half. 1 by half, and this is 1 plus 1 equals to 3 by 2. So the order of reaction is 3 by 2. Because rate law, okay, rate law is this. And if you put the value of concentration of A from the first reaction, okay, and A is what? A is the intermediate. A is the intermediate. So that is root of this what? Concentration of A2 is nothing but your A itself. Okay. So rate law, according to rate law, we know that K is equals to square root of K into A2 and B2. So what is A2? A2 is half, B2 is 1. That is 3 by 2. So the order of reaction is 3 by 2. Is it clear? Okay. So last question. The graph plotted between log K versus 1 by T for the calculating activation energy shown by. Yes. So the plot which is plotted between log K versus 1 by T. It is the plot for so log K versus, so it will be log K versus 1 by T. Okay. So for calculating the activation energy, it is shown by what? It is shown by Arrhenius equation. Okay. It is shown by Arrhenius equation. Okay. So 71st question, the given equation reaction is an example of what order kinetics, the given reaction. It is a which order kinetics? 2 plus 1. It is a third order reaction. Okay, it is a third order reaction. Fine. For the reaction A plus B giving you C plus D, the variation of concentration of the product is given by the curve. So which curve shows the variation of concentration of the products? Yes. How the concentration of the products is variating. Okay. It is shown by Y. Okay. So it shows the increase of concentration of products with time. So as the time proceeds, what is happening to the concentration of the product? It is increasing. Okay. So option number B. Okay. Fine. So these were some of the questions based on chemical kinetics. Okay. So I have tried to solve many questions. Okay. I've tried to cover a lot many questions from chemical kinetics chapter. Okay. So any doubts? Yes. So we have completed the first three chapters from physical chemistry of second year. That is solutions, electrochemistry and chemical kinetics. Okay. So tomorrow we are going to see the chapter D and F block elements. Fine. I hope you have understood everything. Okay. So we'll end the session here. Okay. We'll meet in tomorrow's class. Thank you.